Okay, so we are going to now talk about graphs of relations and functions. So you really need to make sure you've watched the video about functions and what a relation is, and when a relation is a function. Okay, so after this video, these are the things that you should be able to do. You should be able to how relations can be represented using graphs. So we kind of talked about that already, making graphs. How to analyze and determine whether a relation is a function or not. So we've figured out how to determine if something is a function by looking at tables. We've also used arrow diagrams and also ordered pairs, okay? But now you need to know, when is a function, how can I tell if something is a function based on the graph, okay? And this is something that you're going to use to do that. You're going to use the vertical line test, okay? You're also going to figure out how to represent the domain and range of a function using set builder notation and set interval notation. So this is where things can become a little tricky. There's lots of symbols and stuff like that, but once you know how to do it, it's pretty fun and kind of cool. Okay, and then how to determine the domain and range just using words. Okay, so let's review some things that we've learned up to this point, and we've learned a ton, guys. So the domain, these are the elements in the independent variables. Okay, so these are the elements you either choose or you have no control over. The domain values are found on the x-axis, and that's always the horizontal axis. Okay. The range, however, the range are the elements in your dependent variables. Okay, the range is your y-axis or your vertical axis. Okay, then we've talked about coordinate points, also known as ordered pairs. So when you list a coordinate point, you list the domain value and then the range value. That being said, it's easiest to just think of it as your x and y coordinates. Okay, your x coordinates are found on the horizontal axis, and then your y coordinates are found on the vertical axis. Maybe I'll use a different color to represent that so it doesn't get too confusing. We've talked about a function. This is a relation that every domain value has a single corresponding range value. Another way to state it is something is a function when no domain value repeats. Okay, that's the easiest way to think about it. We've talked about ordered pairs. Okay, it's a set that lists domain and corresponding range values. So here's my domain, here's my range. Here's my domain point, here's my extra range point. And then we talked all about function notation. So this, if you want to make sure you understand everything up to this point, you should be able to read each individual point and say, I know exactly what this is talking about. Okay. Now, let's see here. Identifying functions given different contexts. Okay, so we must have the ability to tell if a relation is a function given the following: ordered pairs, arrow diagrams, table of values, and graphs. So we've already done ordered pairs, arrow diagrams, and table of values. We are going to learn about graphs. Recall that the function is something where the domain never repeats. So we just said that. So this is just like a quick little refresher here. So identify if the relations are functions. So here we have an ordered pair. Okay, and remember, something is a function if no domain values repeat. Remember, in an ordered pair, you have a domain value listed first and then the range value. So let's look at our domain values: -1, 0, 3, and 5. So my domain is made up of -1, 0, 3, and 5, and none of these repeats. No repeats. So therefore, this is a function. Okay, so since none of you can see here 5 and 5 show up, but these are range values. Range values can repeat as much as they want. Let's look over here. Where are my domain values? Well, they're always the first listed in our ordered pair. We can see here we have an issue. 2 and 2 pop up twice. So you have a repeating domain value. So what does that mean? That means this thing is not a function. Okay. Let's go down to our tables. Okay, so our tables, remember, our independent variables are always listed on the left. And that makes our left column our domain. Do we see any repeating values here? I definitely do. I see 2 and 2. So here, a domain value repeats. So since the domain value repeats, this is not a function. Okay, let's look over here. Again, do we care what's going on in the range? No, we don't. We always just check out the domain values. So here we can see that nothing repeats. 4, -3, 1, 2, 5. So no repeats. No repeats in domain. So what does that mean? This thing is a function. Okay. So let's move on to this next one here. Now, something that's really important to understand is that a function is usually pretty easy to see as long as you have no repeating domain values. There's one other thing. A domain value must go to a range value in order to be a function. So even though here we have no repeats of our domain values, B needs a corresponding range value. And since this doesn't have a corresponding range value, this is not a function. That's something that everybody always forgets. They just focus on if the domain values repeat. But if you have a lone domain value, that's an issue. That makes it not a function. Over here, you can have a lone range value. It really doesn't matter. What matters is that each domain value has a corresponding range value, as well as A, B, and C don't repeat yourselves. If I had this, I have an issue. That would make it not a function because A repeats. But this is a function. Okay, so hopefully that's kind of making sense. That should have been a bit of a review. If things are confusing on what is and what is not a function, you got to come ask some questions. Okay, now let's look at the graphs here. So what does a function look like on a graph? Surprisingly, it's actually easier to see because what you're going to do is you're going to use something called the vertical line test. So recall, functions have no repeating domain values, as well as functions must be continuous. Okay, so that's really, really important. Your functions have to be continuous. Okay, so that just means that the lines have to connect, or your points are able to connect. Let's see the pattern between a function and a non-function. So something you notice, they're all continuous because they're all just continuous lines. They're not individual plotted points. But this thing is a function, this is not a function, and this is not a function. Notice, because remember, your horizontal line is known as your domain, and your range is your vertical line. Visually, we can see that each domain point here only has an individual range point, right? Over here, though, like this domain point, whatever it is, let's call this A. A has two corresponding range values. Therefore, it is not a function. You can determine these using the vertical line test. So if you can draw a vertical line anywhere on a graph, and the line only intersects the graph once, this means the graph is a function. This is because no domain values are repeating. So let's look at this. Example 2, determine if the following graphs represents a function. So here, I can automatically see if I do the vertical line test, I have more than one intersection point. So this is not a function. Let's go to the next one here. Here, I can put a line anywhere. And sometimes it's nice to use a ruler and then you kind of just go and glide across your graph. But here I can notice that each vertical line only goes through the graph once. This is a function because no domain values repeat. Each individual domain value has a corresponding range value. Over here, this passes the vertical line test, right? We can draw a vertical line anywhere and it only intersects the graph once. So this is a function. Okay. And this guy clearly not. Pretty much everywhere where we draw a vertical line, you're always passing over more than one point. Okay, so we can see that this is not a function. So that's how you use the vertical line. So indeed, it's actually almost a little easier to visually see. Okay, and notice all of these things are continuous, right? So a function not only needs to be passing the vertical line test, it also needs to be continuous. So every domain value needs to have a corresponding range value. Now, let's move forward. If a relation is deemed a function, you then can use function notation. That's why it's called function notation. So as soon as I determine that this graph is known as a function, I could represent whatever the equation is for it as function notation. So here, say the relation can be represented by the equation y equals 2x. Well, this thing is a function. And as soon as you know that this thing is a function, you can then describe it using function notation. So I'm going to replace y with f of x. Okay. Okay, so I'm going to stop the video there because the next thing is domain and range, and that's a whole nother video on itself. So I would go suggest practicing figuring out what's a function and what is not a function. Remember, and let's do just a quick little review, and you want to write this on your forehead. So review, what is a function? It has two criteria. It has no repeating domain value and all domain values need a corresponding range value. Okay, so remember, up here, this was not a function because even though there's no repeating, you have a lone domain value. This has no other range value attached to it. On a graph, that means it has to be a continuous graph. So here, this has to be continuous. So essentially, as soon as you're dealing with discrete data, that probably means it's not a function. Okay, so go practice finding domain or figuring out what's a function because it's very important to practice. You can use your textbook. I would suggest opening up to 5.5. Other than that, have a good day.